For my standard 1.1, I chose to do question 1.6 from our textbook. It tells us that there is a beam of spin 1/2 particles that are prepared in this state. Part A asks us, what are the possible results of a measurement of the spin component S sub z and with what probabilities would this occur? So the possible results of the measurement of the spin component S sub z are the eigenvalues of the S sub z operator, which are plus or minus h bar over 2. Then it follows from this that the probabilities are the absolute values of the coefficient squared. So for our spin up probability, it would be 2 over 13, or over square root of 13 squared. So here's our coefficient, and down here is squared. So that gives us 4 over 13, and our spin down probability is 3 over square root of 13, which is the coefficient right here, squared, and this equals 9 over 13. As expected, these add up to 1 since these are only two possible states. For part B, we are asked, what are the possible results of a measurement of the spin component S sub x and with what probabilities would these occur? So again, the possible results of the eigenvalues of S sub x are h bar over 2. The probabilities then can be found from the coefficients in the expansion. It follows for using expressions for plus or minus the spin up or spin down state in the eigenspace x is this. So you see we multiply these together and we get this, which this is the coefficient of the expansion of this function in the spin up sub x basis. Its absolute value squared is then this, which gives us 1/2. Then the calculation for p sub x is calculated the same and is also 1/2. And we can also tell this that the probabilities have to add up to 1. So if our spin up basis or spin up probability is 1/2, then our spin down probability would have to be 1/2. Part C scrolls down. Here is a histogram of my results from part A, or from part A and part B. So here's the probabilities in the S sub z basis, and then for the S sub x. And that's it.